Did you know that light can actually knock electrons out of metals? No hammer, no touching, just light. Come with me. You see, on today's video, I'm going to be teaching one of the most feared physics calculation questions across several exam boards, and it is on the photoelectric effect. Before I proceed, if you are a parent or you are a student preparing for any of the external exams and you are going to write physics, please save this video. You are going to find it very beneficial, and don't forget to follow this page for further explanations. Now let's begin. We are told that light of frequency 7.5 times 10 raised to power 14 Hz shines on a metal surface with work function 3.0 times 10 to the power minus 19 joule. When we are told to calculate A, the maximum kinetic energy of the emitted photoelectrons, and B, the stopping voltage needed to stop them. Now, first thing first, let me explain the concept of the photoelectric effect for you. Okay? Now, imagine tiny bullets of light flying through space, okay, and then hitting metal surfaces. Now, in physics, these tiny bullets of light are called photons. Okay, now each of these photons contain a certain amount of energy. Now, as these tiny bullets of light, otherwise called photons, are flying through space and then they hit a metal surface, if the energy of this bullet of light, these photons, if it is strong enough, it can knock out electrons from these metal surfaces. Now, that phenomenon whereby light falls on the metal and then electrons are emitted or liberated is what we call the photoelectric effect. And the electrons being emitted are called the photoelectrons. I believe that is clear. Now, let's look at the question. First thing first, we bring out our parameters. Okay? We bring out our parameters. Now, what were we giving? Light of frequency 7.5 times 10 to the power 14 Hz. So I've been given the frequency. So I know my frequency F is equal to what? 7.5 times 10 to the power 14 Hz. Let's move on. Shines on the metal surface with work function. Work function. So I've been given my work function W, all right, to be what? 3.0 times 10 to the power minus 19 joules. Okay, and then we have to calculate the maximum kinetic energy and then the stopping voltage. But before we proceed, the first thing you have to look for is the energy of the photon. Okay, we have to look for the energy of the photon. The energy of the photon. Energy of the photon. Now, in physics, energy of the photon is calculated as what? HF. H times F. What do we mean H? H is simply a constant known as Planck's constant, okay? And it's equal to 6.63 times 10 to the power minus 34. All right? And F is your frequency already given in the question. So that means we can calculate for the energy of the photon. All right? So energy is equal to H, like I said, is Planck's constant, 6.63 times 10 to the power minus 34. Then times frequency. What is frequency? 7.5 times 10 raised to the power 14. Now, before I proceed, there's something I want to show you here. Energy is equal to Planck's constant times frequency. That means energy is dependent on Planck's constant and frequency. Take note, frequency, not intensity. Because many times, students get to interchange frequency for intensity. When it comes to energy, frequency is what determines the energy or the speed of the electrons. Okay, please take note of that. So frequency is what determines energy, not intensity. Intensity only affects the number of photons hitting the metal surface per time. I say that again. Intensity only affects the number of photons, that's the quantity. So when you talk of intensity, intensity affects the quantity of photons hitting the metal surface per time. But when you are talking about the energy of the photon or the speed, it is determined by frequency. I believe that is clear. So energy equals to this, multiply this. So if you multiply that, you have that energy equals what? 4.97 times 10 raised to the power what? Minus 19 joules. So this becomes the energy of the photon. Now, another thing you must know, not all of this energy will be converted to the speed or the kinetic energy of the electrons. No. All right. Some of this energy will first be used to free the electrons from the metal. Okay. And then what is left will now be the speed of the electrons. Now, that quantity of energy that is first used to free the electrons from the metal is what we call the work function. Then what is left is now the speed of the electron. So therefore means that this energy of photon equals work function plus the speed of the electron. That's the kinetic energy. So I can say energy of photon equals work function, all right, plus what? Kinetic energy of photoelectrons. All right. Now, don't forget for question A is what we're asked to look for. The maximum kinetic energy of the emitted photoelectrons. So I'm going to make Ke of photoelectrons subject to formula. How do I do that? Work function with crossover. Now, remember in mathematics, when a positive number is crossing over, it becomes negative. So what it means is that kinetic energy of photoelectrons is equal to what? Energy of photons. All right, energy of photons. Now, work function is going to cross over now. Plus changes to what? Minus. Minus what? My work function. All right. So what I did is just to collect like terms. So collect what? Like terms. So let's go. So kinetic energy now equal to what? What's the energy of photon? Already calculated. 4.97 times 10 to the power minus 19. All right. What's the work function given in the question, right? 3.0 times 10 to the power 19 times 10 to the power what? Minus 19. All right. So if you do that with your calculator very well, you discover that the kinetic energy equals what? 1.97 times 10 to the power minus 19. All right. Since both powers are the same, minus 19, you subtract the whole numbers. Okay. So 4.97 minus 3, that gives you 1.97 times 10 to the power minus 19 joules. So the kinetic energy is 1.97 times 10 to the power minus 19 joule. Now let's solve for the B part, the stopping voltage needed. The stopping voltage needed. Okay. The stopping voltage. Now, what do we mean stopping voltage? Now, stopping voltage is simply the minimum voltage that must be applied to stop the fastest photoelectron from crossing to the other side of the circuit. Okay, the minimum voltage that must be applied in the opposite direction to stop the fastest photoelectron. Now, the formula is given as this. EV equal to maximum kinetic energy. Now, take note of that. EV equal to maximum kinetic energy. What is E? E is simply the charge of an electron. It's a constant. And it's equal to 1.6 times 10 to the power minus what? 19. Then V is the stopping voltage. Then kinetic energy is what we have already calculated for. So let's do that. We have E, that's the charge of an electron. I told you it's a constant, equal to what? 1.6 times 10 to the power minus 19. Times V, that's the stopping voltage, equals to the kinetic energy already calculated, all right? That's 1.97 times 10 to the power minus what? 19. So how do I get V? I divide both sides by the coefficient of V, which is the E now, the charge of the electron. That's 1.6 times 10 to the power minus 19 divided by 1.6 times 10 to the power minus 19. I guess you're following. So this takes care of this. So I have my V, that stopping voltage, equals to this. So what we do, we divide that. If you divide that properly, you have 1.23 volts. Therefore means that the stopping voltage, that's the minimum voltage applied in the opposite direction to stop the fastest photoelectron is 1.23 volts. Now, this is exactly how I teach. I make complex concepts to be very easy. Now, if this video has helped you to understand photoelectric effect, just imagine how a full one-on-one session with me would affect your exam grade. So if you are preparing for any of the external exams, GCSE, SAT exams, A-level, WAEC or JAM exams, and you want to step into that exam confidently, why don't you book a session with us by sending a direct message to me using the number now displayed on your screen, or you send us an email so we can get you exam ready. I am Tutor Frank, and I teach you patterns nobody ever taught you. Don't forget to follow this page. Bye.